It is legal to have a chiller fed directly from a bus duct swing plug that is within sight, provided certain conditions are met. These conditions are: firstly, the bus duct swing plug is the only means of disconnect. Secondly, the bus duct swing plug is readily accessible and operable. Thirdly, the swing plug is within sight of the chiller. Now, regarding NFPA 79 enforceability, it's important to understand that NFPA 79 itself is not a law. Instead, it is a widely recognized and accepted standard for the installation of electrical equipment. If a local authority having jurisdiction, OJ, has adopted NFPA 79, it may be enforceable within that specific jurisdiction. Looking into NFPA 79 requirements, it mandates that electrical equipment have a disconnect switch within sight of the equipment. However, it is important to note that it does not specify the height at which the disconnect switch must be located. Regarding recommendations, even though not explicitly required by NFPA 79, it is generally recommended that disconnect switches be located at a lower level for enhanced safety. This positioning makes it significantly easier to access and operate the switch, particularly in emergency situations. In conclusion, while it is indeed legal to have a chiller fed directly from a bus duct swing plug that is within sight, the recommendation stands to locate the swing plug at a lower level to bolster safety measures. Should concerns arise about the enforceability of NFPA 79 within a specific jurisdiction, consulting with the local AHA is advisable to ensure compliance and safety. Considering this further, electrical installations must adhere to all applicable codes and standards to ensure safety and proper functionality. The National Electrical Code, NEC, provides comprehensive guidelines for electrical installations, including requirements for disconnects and overcurrent protection. When evaluating the legality and safety of a chiller installation, it is essential to consider several key factors. Firstly, the accessibility of the disconnect means. The disconnect must be readily accessible to qualified personnel for maintenance and emergency situations. This accessibility includes ensuring that the disconnect can be reached without the need for ladders or other specialized equipment, especially in emergency scenarios. Secondly, the visibility of the disconnect. The disconnect must be within sight of the equipment it serves, typically within 50 feet, unless specific exceptions apply. This visibility allows personnel to verify that the equipment is energized before performing any work. Thirdly, the type and rating of the disconnect. The disconnect must be suitable for the voltage, current, and application of the equipment it serves. This suitability ensures that the disconnect can safely interrupt the electrical supply under normal and fault conditions. Fourthly, the compliant with NFPA 70, the National Electrical Code. The installation must comply with all relevant requirements of the NEC, including those related to disconnects, overcurrent protection, and grounding. Examining NFPA 79 in greater detail, it specifically addresses the electrical standard for industrial machinery. It aims to ensure the safety of personnel and equipment by establishing requirements for the design, construction, and operation of electrical systems used in industrial machinery. Although NFPA 79 is not a legal requirement in all jurisdictions, it is widely recognized and often adopted as a best practice or mandated by local authorities. Compliance with NFPA 79 can significantly enhance the safety and reliability of industrial electrical systems. The key aspects of NFPA 79 include: firstly, disconnect requirements. NFPA 79 requires that each piece of industrial machinery have a main disconnect switch that can energize all electrical circuits within the machine. This disconnect must be readily accessible and clearly marked. Secondly, overcurrent protection. NFPA 79 requires that all electrical circuits within the machine be protected against overcurrent conditions such as short circuits and overloads. This protection is typically provided by fuses or circuit breakers. Thirdly, grounding. NFPA 79 requires that all metal parts of the machine be properly grounded to provide a path for fault current and to protect against electric shock. Fourthly, control circuit requirements. NFPA 79 specifies requirements for the design and construction of control circuits, including those used for motor control, safety interlocks, and emergency stop functions. Fifthly, wiring and cabling. NFPA 79 specifies requirements for the selection, installation, and protection of wiring and cabling used within the machine. Sixthly, marking and labeling. NFPA 79 requires that all electrical components and circuits within the machine be clearly marked and labeled to facilitate identification and maintenance. If a local authority having jurisdiction or OJ has adopted NFPA 79, compliance with its requirements becomes mandatory. The AHA is responsible for enforcing electrical codes and standards within their jurisdiction and has the authority to interpret and apply these requirements to specific installations. Consulting with the local AHA is essential to determine the specific requirements that apply to a particular installation and to ensure compliance with all applicable codes and standards. When evaluating the height and location of disconnect switches, several factors should be considered to ensure safety and accessibility. Firstly, the accessibility for maintenance personnel. Disconnect switches should be located at a height that allows maintenance personnel to safely and easily operate them without the need for ladders or other specialized equipment. A typical height ranges between 3 feet and 6 feet above the finished floor or working platform. Secondly, the visibility from the equipment. Disconnect switches should be located within sight of the equipment they serve, allowing personnel to verify that the equipment is de-energized before performing any work. Thirdly, the protection from physical damage. Disconnect switches should be located in a manner that protects them from physical damage, such as from forklifts or other equipment. Fourthly, the compliance with accessibility requirements. Disconnect switches must comply with accessibility requirements for persons with disabilities, as specified in the Americans with Disabilities Act, or ADA, and other applicable regulations. In situations where a bus duct swing plug is used as the sole means of disconnect for a chiller, it is important to carefully evaluate the installation to ensure compliance with all applicable codes and standards. While it may be legal to use a swing plug as the disconnect, it is essential to consider the following factors. Firstly, accessibility of the swing plug. The swing plug must be readily accessible to qualified personnel for maintenance and emergency situations. If the swing plug is located 20 feet above the chiller, it may not be considered readily accessible unless a permanent means of access, such as a platform or elevated walkway, is provided. Secondly, the visibility of the swing plug. The swing plug must be within sight of the chiller, allowing personnel to verify that the equipment is de-energized before performing any work. Thirdly, the rating of the swing plug. The swing plug must be rated for the voltage, current, and application of the chiller it serves. Fourthly, a compliance with NEC requirements. The installation must comply with all relevant requirements of the NEC, including those related to disconnects, overcurrent protection, and grounding. Given the potential safety concerns associated with locating a disconnect switch at a height of 20 feet, it is generally recommended to install a separate disconnect switch at a lower level for easier access and operation. This additional disconnect switch can provide a more convenient and safer means of de-energizing the chiller for maintenance and emergency situations. The installation of a separate disconnect switch should comply with all applicable codes and standards, including the NEC and NFPA 79, if adopted by the local AHA. In summary, while it may be legal to use a bus duct swing plug as the sole means of disconnect for a chiller, it is essential to carefully evaluate the installation to ensure compliance with all applicable codes and standards. It is generally recommended to install a separate disconnect switch at a lower level for easier access and operation, particularly in emergency situations. Consulting with the local AHA is advisable to determine the specific requirements that apply to a particular installation and to ensure compliance with all applicable codes and standards. For instance, concerning the National Electrical Code, or NEC, it is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect changes in technology and best practices. Understanding relevant NEC articles is crucial for ensuring electrical safety and code compliance. Several articles in the NEC directly relate to disconnects for equipment, including chillers. Firstly, NEC Article 430 covers motors, motor circuits, and controllers. Since chillers often use motors, this article is highly relevant. It specifies requirements for motor disconnects, including their location, rating, and type. Secondly, NEC Article 440 addresses air conditioning and refrigeration equipment. This article supplements the general requirements of Article 430 and provides specific rules for disconnects serving air conditioning and refrigeration equipment, such as chillers. Thirdly, NEC Article 620 covers elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway-chair lifts. This article is relevant if the chiller is part of a system covered by Article 620. Fourthly, NEC Article 110 provides general requirements for electrical installations, including disconnect. This article covers issues such as working space around electrical equipment, guarding of live parts, and identification of disconnecting means. Several specific NEC sections are particularly relevant to disconnects for chillers. NEC 430.102 addresses location. This section requires that a disconnecting means be located within sight from the motor controller and the motor location. The intent is to provide a readily accessible means of disconnecting the motor for maintenance and safety purposes. If the disconnecting means is not within sight, it must be lockable in the open position. NEC 430.109 addresses types of disconnects. This section specifies the types of disconnecting means that are permitted for motors depending on the motor horsepower and voltage. Common types of disconnects include motor circuit switches, molded case circuit breakers, and horsepower-rated switches. NEC 440.14 addresses location of disconnects for air conditioning and refrigeration equipment. This section requires that a disconnecting means be located within sight from and readily accessible to the air conditioning or refrigeration equipment. The disconnecting means must be capable of being locked in the open position. NEC 440.12 addresses rating and interrupting capacity. This section specifies the minimum rating and interrupting capacity of the disconnecting means for air conditioning and refrigeration equipment. The disconnecting means must be capable of interrupting the locked rotor current of the motor and any other loads served by the equipment. NEC 110.26 addresses working space about electrical equipment. This section requires that sufficient working space be provided around electrical equipment, including disconnects, to allow for safe operation and maintenance. The working space must be clear and unobstructed. Considering a specific example, suppose a chiller is installed in a mechanical room and is fed by a 480-volt, three-phase circuit. The chiller has a motor controller located next to the chiller, and the disconnecting means is a motor circuit switch located within sight of both the controller and the chiller. The motor circuit switch is rated for the motor horsepower and voltage, and it is lockable in the open position. The installation also complies with NEC 110.26, providing sufficient working space around the motor circuit switch. In this case, the installation would likely comply with the relevant NEC requirements for disconnects. However, if the disconnecting means were located out of sight from the chiller or controller, or if it were not lockable in the open position, the installation would not comply with the NEC. Similarly, if the disconnecting means were not properly rated for the motor horsepower and voltage, it would not comply with the NEC. In summary, understanding the NEC requirements for disconnects is essential for ensuring electrical safety and code compliance. By following the relevant articles and sections of the NEC, electrical contractors and engineers can design and install electrical systems that are safe, reliable, and compliant with applicable codes and standards. Consulting with a qualified electrical inspector or engineer is recommended to ensure that all NEC requirements are met. Moreover, concerning the bus duct swing plug, it's crucial to ensure it meets safety and code requirements. A bus duct is a prefabricated electrical distribution system used to efficiently and safely distribute power in commercial and industrial settings. It consists of a series of metal enclosures containing busbars, which are conductive bars made of copper or aluminum. Bus ducts are designed to carry large amounts of electrical current with minimal voltage drop, and they offer flexibility in terms of layout and expansion compared to traditional wiring methods. Key components of a bus duct system include firstly bus bars. These are the conductive bars that carry the electrical current. They are typically made of copper or aluminum and are insulated to prevent short circuits. Secondly, housing. The housing is the metal enclosure that contains the bus bars. It provides physical protection for the bus bars and helps to prevent electrical hazards. Thirdly, insulators. Insulators are used to support and insulate the bus bars within the housing. They are typically made of ceramic or epoxy materials. Fourthly, tap boxes. Tap boxes are used to connect electrical loads to the bus duct system. They contain circuit breakers or fuses to provide overcurrent protection for the connected loads. Fifthly, end closures. End closures are used to seal the ends of the bus duct system and provide protection against environmental factors. Sixthly, fittings. Fittings are used to connect different sections of the bus duct system and to change direction. There are several types of bus duct systems, each designed for specific applications. Firstly, feeder bus duct. This type of bus duct is used to distribute power from the main electrical service to various loads throughout a facility. It is typically installed in a straight line and is available in various sizes and ampacities. Secondly, plug-in bus duct. This type of bus duct has openings along its length where tap boxes can be plugged in to connect electrical loads. It offers flexibility in terms of load placement and is commonly used in manufacturing plants and other industrial settings. Thirdly, isolated phase bus duct. This type of bus duct is used in high current applications such as power plants and substations. It consists of individual bus bars that are each enclosed in a separate grounded metal housing, which helps to reduce electromagnetic interference and improve safety. Bus duct systems offer several advantages over traditional wiring methods. Firstly, high current capacity. Bus ducts can carry large amounts of electrical current with minimal voltage drop, making them suitable for high power applications. Secondly, flexibility. Bus ducts offer flexibility in terms of layout and expansion, allowing for easy modification and addition of electrical loads. Thirdly, space saving. Bus ducts can be installed in a compact space, reducing the overall footprint of the electrical distribution system. Fourthly, safety. Bus ducts are designed to provide a high level of safety, with features such as insulated bus bars, grounded housings, and overcurrent protection. Fifthly, ease of installation. Bus ducts are prefabricated and easy to install, reducing installation time and costs. When installing and maintaining bus duct systems, it is important to follow all applicable codes and standards such as the NEC and the standards of the National Electrical Manufacturers Association, or NEMA. Regular inspections and maintenance are also essential to ensure the safe and reliable operation of the bus duct system. A swing plug, also known as a tap-off unit or plug-in unit, is a device used to connect electrical equipment to a plug-in bus duct system. It typically consists of a housing containing a circuit breaker or fuses, a plug that connects to the bus duct, and a cable or conduit that connects to the electrical equipment. Swing plugs are designed to provide a safe and convenient means of connecting and disconnecting electrical loads from the bus duct system. Key features of swing plugs include firstly, circuit breaker or fuses. Swing plugs contain a circuit breaker or fuses to provide overcurrent protection for the connected equipment. The circuit breaker or fuses are sized to match the load requirements of the equipment. Secondly, plug. The plug is designed to mate with the openings in the plug-in bus duct. It provides a secure and reliable electrical connection between the bus duct and the swing plug. Thirdly, cable or conduit connection. Swing plugs have a cable or conduit connection for connecting the electrical equipment. The cable or conduit is sized to match the current requirements of the equipment. Fourthly, housing. The housing provides physical protection for the internal components of the swing plug and helps to prevent electrical hazards. Fifthly, handle or lever. Swing plugs typically have a handle or lever for easy insertion and removal from the bus duct. When selecting and installing swing plugs, it is important to consider the following factors. Firstly, ampacity rating. The swing plug must be rated for the current requirements of the connected equipment. Secondly, voltage rating. The swing plug must be rated for the voltage of the bus duct system. Thirdly, interrupting capacity. The circuit breaker or fuses in the swing plug must have sufficient interrupting capacity to safely interrupt fault currents. Fourthly, environmental conditions. The swing plug must be suitable for the environmental conditions in which it will be installed, such as temperature, humidity, and exposure to corrosive substances. Fifthly, code compliance. The swing plug must comply with all applicable codes and standards, such as the NEC and the standards of UL. When using a swing plug as the sole means of disconnect for a chiller, it is important to ensure that the swing plug is readily accessible and can be locked in the open position. The swing plug must also be located within sight of the chiller unless other means of disconnect are provided. The height at which the swing plug is installed should also be considered, as accessibility can be an issue if the swing plug is located too high above the floor. Regular inspections and maintenance of swing plugs are essential to ensure their safe and reliable operation. Inspections should include checking for loose connections, damaged components, and proper operation of the circuit breaker or fuses. Maintenance should include cleaning and tightening connections as needed. In summary, bus duct systems and swing plugs are important components of electrical distribution systems in commercial and industrial settings. Understanding their features, advantages, and limitations is essential for ensuring the safe and reliable operation of electrical equipment. Consulting with a qualified electrical engineer or contractor is recommended to ensure that bus duct systems and swing plugs are properly selected, installed, and maintained. For example, in a large manufacturing plant, plug-in bus duct system is used to distribute power to various pieces of equipment. Swing plugs are used to connect the equipment to the bus duct. Each swing plug contains a circuit breaker to provide overcurrent protection. The swing plugs are located within sight of the equipment they serve and are readily accessible for maintenance. In another example, in a high-rise office building, a feeder bus duct system is used to distribute power to the various floors. Tap boxes are used to connect electrical panels to the bus duct. The tap boxes contain circuit breakers to provide overcurrent protection. The bus duct system is installed in a vertical shaft and is designed to minimize voltage drop and ensure reliable power distribution throughout the building.